Hi, we're going to talk today about expanding logarithmic expressions. First of all, these properties of logarithms, they are going to be helpful to you, especially the first three, because these are the ones that deal with situations when you have a product, a quotient, or an exponent inside of a log and how to address that. The general rule for expanding logarithmic expression is that you do not keep products in the logs, quotients. You do not keep exponents, radicals, or you do not leave any logarithms that can be evaluated without a calculator. And we're going to see all that. The example here is if you're going to end up with getting, for example, log base 232, that is actually 5, because 2 to the 5th power is 32. So let's take a look how this works, and I'm going to be coming back to this to point out what properties we're using. So the first example is log base 3 of x cubed y. X cubed y, a product of the two. For a product, we're going to use this property that tells you if you have a log of a product, we're going to write it as the sum of two logarithms. So we're going to first write that as log base 3 x cubed plus log base 3 of y. So we do not have the product anymore, but we still have an exponent here. And for an exponent, right here there's a property that tells you if you have an exponent, you're going to put it in front of the log. So this 3 here is going to go in front. There is nothing we can do here, it's as simple as it gets. So the answer here is going to be 3 times log base 3 of x plus log base 3 of y, and that is the answer here. Example 2 is log base 2 of 16 cube root of m. Similar to this, we have a product, so that's the first thing we're going to address. So it's going to be log base 2, 16 plus log base 2 of cube root of m. There's a couple of things here. We are not allowed to leave radicals, but we don't know how to do radicals, so we're going to need to rewrite that in a form that we can handle. But this logarithm here is actually going to equal 4, because 2 to the 4th power is 16. So this is 4 plus log base 2 of m. Cube root of m is the same as m to the power 1/3. So then we're going to get 4, and this 1/3 is going to be brought in front as because it's an exponent. 4 plus 1/3 times log base 2 m. And we are done with this problem. The next problem, example 3, has a quotient. So in the quotient, right here, when you see a log of a quotient, you're going to write it as the difference of two logarithms. So the first thing we are going to do is write that as log base 5p minus log base 5 of q to the 5th. The exponent goes in the front. And we're going to have log base 5p minus 5 log base 5q. Okay, let me rewrite that. Okay, as always, we're going to look for things like products inside logs, or quotients, exponents, radicals, and we don't have any of that here. We simplified that and expanded it as much as we could. Next problem also has a quotient. I do want to remind you that here we have a log with no explicitly written base. That means the base is 10. So it's going to be log square root of y. Quotient means we do minus log 100. Log base 10, this is base 10, of 100. 10 to what power equals 100? That would be 2. And this here we're going to write as log y to the power 1/2. We already know this is going to be 2. The exponent here goes in the front, and we're going to get 1/2 times the log y minus 2. And a few more problems to look at. Some of them are a little bit more complicated. Let's do them carefully. This one here. So we have log base 7 of n cubed over w to the 4th times the 5th root of u. So we're going to start by doing the following. Log base 7 of n cubed. First of all, we're going to break down the quotient. Minus log base 7 of w to the 4th times the 5th root of u. We do have a product here, and what I would suggest here, because we have a minus, you can do it when you have a plus as well, is to put it in the bracket so that you can do it correctly. With this one, we can take care of this 3 and put it in front. That means we're getting 3 times the log base 7 n minus, put my bracket here. This is a product, so we're going to write it as a quotient, as a difference of two things. It's going to be log base 7 of w to the 4th plus log base 7 of 5th root of u. We can take this 4 out and put it in front of the log. This here can be written as u to the power 1/5. So the 1/5 can go out. So we're going to get 3 times the log base 7n minus, we still have the bracket here. Kind of running out of space, but we'll manage. Times 4 log base 7w plus 1/5 log base 7u. Here's a very important thing you need to remember. This negative here has to be distributed. This is the same as having -1. So before you can just drop the brackets here, you need to distribute -1. And the final answer here will be 3 log base 7n minus 4 times log base 7w minus 1/5 log base 7u. The next problem, we do have a product here, 2 times this. So the first thing we're going to do is break it up. We're going to get log base 4 2 plus log base 4 x plus 2 cubed. We should already realize that the 3 goes in the front. What's log base 4 2? 4 to what power gives you 2? That would be 1/2. So this is going to become 1/2 plus 3 times the log base 4 x plus 2. Here's a very important thing. This is actually the answer. And I want to make this side note here that log base b of m plus n does not equal to log base b m plus log base b n. There is no distributive property. It's very important. So if it has a sum, it's going to stay like that. That x plus 2 is going to stay like that. Next problem, we have a quotient. So log base 3 of 2x minus 3 minus log base 3 of x squared plus 1 to the 5th. The exponent here will go in the front. So we're going to get log base 3 2x minus 3 minus 5 log base 3 of x squared plus 1. Same thing that I mentioned here. You cannot distribute that in any way. This is precisely how it's going to stay. This last example, this has ln. This is when the base is e. It may matter in a way. We'll see. The first thing we're going to do is realize that there's a quotient here. So we're going to write that as ln e to the fifth minus ln x squared. So what's ln e to the fifth? That's the question. When you raise e to what power, you're going to get e to the fifth. That would be 5. That should be pretty obvious. So this here gives you 5. The exponent here is going to go in the front. And your answer will be 5 minus 2 times ln x. And that takes care of the problem. That concludes our lesson for today. I appreciate any comments, or if there's anything that you have questions on or any other videos you want to do, please let me know too. I hope this helps.